Here in this slide, we will see step by step how to analyze and design the T or L beam. So first of all is capacity analysis. As we know that in capacity analysis, we have known the cross-sectional dimension such as B, D, BW, HF, L, material properties, FC dash, Fy and area of steel. And we are required to find the flexural capacity, which is phi BMN. So step number 1 is check whether the slab is in tension or not. If yes, then analyze as a rectangular section. Step number 2 is assume that neutral axis to be within the flange and calculate the A and C. A is equals to AS Fy divided by 0.85 Fc dash into B, and from here we will get the C value. C is equals to A over beta 1. If C is less than HF, meaning to that our assumption is correct and beam needs to be designed as a rectangular beam. On the other hand, if C is greater than HF, then beam needs to be designed as a T-beam. So step number 3 is ASF is equals to 0.85 beta 1 HF into FC dash over Fy into B minus BW. Step 4 is we need to calculate ASW, which is equals to AS minus ASF. Now we need to revise the A. A is equals to ASW Fy divided by 0.85 Fc dash into BW. Now need to calculate epsilon S and phi factor. If A is less than equals to beta 1, 3 by 8 D, phi is equals to 0.9. Now flexural capacity for under reinforced section for T beam is phi B Mn is equals to phi B ASW into Fy into D minus A by 2 plus phi B ASF into Fy into D minus beta 1 HF divided by 2. This is the flexural capacity. Now let's see example for T-beam. Statement is a T-beam has the following data. B is equals to 800 mm, BW is 350 mm, HF is 125 mm, FC dash is 20 megapascal, Fy is 420 megapascal, D is 450 mm. We need to determine the flexural strength for the following two cases if slab is in compression. AS is equals to 3900 millimeter square and AS is equals to 3000 millimeter square. Now in this particular example, we know HF, L, FC, Fy, load or MU, and we need to find out basically cross-sectional dimension, beam size, area of steel, detailing and bar bending schedule. So first step is select the trial dimension of the beam BW and H nearly same for the as for the rectangular section. Step 2 is calculate the effective width. Step 3 is assume neutral axis at the junction of flange and web somewhere here. Means A1 is equals to beta 1 HF and AS is equals to MU divided by 0.9 Fy D minus A by 2. And if A2 is less than beta 1 HF, our assumption is correct and beam needs to be designed as a rectangular beam. Now, if A2 is greater than beta 1 HF, then beam needs to be designed as a T beam. So we need to calculate ASF, which is equals to 0.85 beta 1 HF into FC dash over Fy into B minus BW. Now we need to calculate phi B MNF, which is equals to 0.9 ASF Fy into D minus beta 1 HF by 2. Step 6 is basically we need to calculate MW, which is total moment, MU minus MF. Now we need to calculate ASW and we need to calculate A. Step 8 is we need to calculate total area of steel, which is ASF plus ASW. Step 9 is we need to calculate rho W, which is equals to AS divided by BW into D. Step 10 is we need to check for rho max and rho minimum. And at the end, step number 11 is we need to prepare a structural drawing or construction drawing, or we need to prepare a bar bending schedule for the selected beam and its reinforcement. In the previous slide, I will give you step-by-step hint for the analysis of the T-beam. Now, there is an example in your book for the design of T-beam, and statement is design a T-beam to be used as interior simply supported beam of span 5 meter. The slab panel on both sides of beam are 3.5 into 5 meter. Factor slab load is 15 kilonewton per meter square. FC dash is given, which is 17.25, and Fy is 420 megapascal. Use BW equals to 300 millimeter, HF 125 millimeter, H 575 millimeter. Use SI bar designed for given loading, and second case is designed for MU equals to 800 kilonewton. So this is the design example. You can follow that example from the book, and next time I will solve that example as well. This particular lecture is basically for the analysis and design of T and L beam. So I would highly suggest you kindly read from the book, and if you have any question you can ask me. Thanks.